Auxiliary fuel tanks. Hey everyone, I'm Simon, the CTO of ScaleWings aircraft, and in that video I will introduce the auxiliary fuel tanks for the ScaleWings SW-51 Mustang. Everything you need to know you will find in this video. Let's go. Alright, let's start with the value add. What do you get? Actually, you get another 1 hour 45 minutes of flight time or 330 nautical miles at maximum cruise power setting. In this sample, you can see a flight profile where we assume cruising at maximum cruise power setting in flight level 150, which is giving you about 180 knots true airspeed. And in that sample, you can already achieve a range of 270 nautical miles. That one is referring to about 1.5 hours of flight time plus 1 hour reserve. So we will never touch the reserve. We always consider 1 hour of reserve at maximum cruise power setting. Now, with the additional auxiliary fuel tanks, you can double the range to a total range of about 600 nautical miles by adding the 330 nautical miles or the 1 hour 45 minutes. That is what you get with the new fuel tanks. Now, how we achieve that? We increase significantly the fuel capacity. The present solution is that we have two fuel tanks, one on each side here in the center wing, and the total amount is 26 US gallons, 13 aside. Now we add another 18 US gallons, 9 per side, here with the auxiliary fuel tanks installed in the outer wings, meaning the future fuel amount will be 44 US gallons. Now, how that system look like, let me show you a video. Now you can see the outer wing shell, and also the main assembly of the structure. This is the main structural element, the wing spar. And now you can see here are ribs coming into the wing. And those three ribs are basically hosting the auxiliary fuel tank, which is now in building here. And we just slide it into the outer wing. Then there is also a filler cap where you can refill the auxiliary fuel tank. Now here are some pictures how the design look like and how it is installed. As said, here are the three additional ribs with the auxiliary fuel tank installed. Very important for us was also that the system installation area here is not affected by that design, because here are the taxi and camera lights, and that can be still done. So that is well interacting. And yeah, and then you can find here a little hole, and that one will be used to connect the auxiliary fuel tank with the main tank by a flexible fuel hose, which is running here underneath the wing spar into the center wing tank. Now, why we make it in that way, that it have to be routed like this? It is about the center of gravity. The aircraft is slightly tail heavy, and to avoid additional weight in the back, we install the auxiliary fuel tank in front of the wing spar. And this installation is almost center of gravity neutral. So the impact to the CG is almost nothing. And that is, let's say, a big advantage, as then you don't need to take care a lot about the move in the center of gravity. Now let's talk about some details of this fuel installation, how it is actually working. Basically, it is a mixture of a mechanical and an electrical system. Mechanical, because we have a gravity feed from the auxiliary fuel tank to the main fuel tank, as the aircraft, the wing has a V shape. And the auxiliary fuel tank is sitting at the outside, while here is the main tank. So it is higher. And because it's higher, it has hydrostatical pressure, feeding automatically the main fuel tank. Now in this chart, we just made one more slide update. So it's not feeding the supply line, it's feeding the tank directly. But before it is the the gravity is feeding the fuel from the auxiliary to the main, there is a valve, an electrical valve. And this electrical valve you can find here. And this valve is usually closed. If there is no electricity, no power on the valve is closed. And just with electricity, this valve will open. Now, how it will open, we will have three modes, which I'll show you in a second. But to the, let's say, default mode, the default mode will be an automatic mode. And in that automatic mode, the fuel sensor of the main fuel tank will control the electricity of this electrical valve. So you consume fuel, then the fuel sensor goes down because it's a floating type fuel sensor. So it goes down. And now it is passing electricity to the fuel valve. The fuel valve of the auxiliary fuel tank opens and you fill up the main fuel tank again. And then the fuel sensor, the floating type, will move up and close it again. This is how it works like for several times until the point the auxiliary is empty. Just some other elements for your information. So here you can see the shut-off and fuel selector valve. So you can select left, right, both or off. And then it is, let's say, once it passed the fuel selector valve, it is going into a fuel filter. Then it is going through the fuel pump assembly, which you can see here. Basically, it is like that we have two electrical pumps. There's no mechanical pump. And fuel pump 1, fuel pump 2. And in the regular case, here's a fuel filter. So fuel comes in here, goes through one pump. Now let's say just this one is switched on, then it goes that way. Here's a check valve where fuel cannot return anymore. So once passed, there's no way of return. And then it passes another fuel filter and it goes to the engine. And from the engine, every fuel which is not consumed is going through a return line, a bypass line, back into the actual selected fuel tank. Now, if this fuel pump fail, you use that pump as an alternative, and then the fuel just is bypassed and is going here through that fuel pump. If both pumps are working, also possible, I usually fly with both pumps on, and then the fuel just go through both pumps and into the engine. Yes, which element we have here as well is this mechanical lever valve. And why we install that valve is installed here. And because the outer wing is still removable. So we have the center wing, which is permanently mounted towards the fuselage, but then we have the outer wing. And the outer wing can be removed, for example, for trailer transportation on ground. And then during the disassembly, you need to open that valve, the lever, and then you can disconnect the fuel line here, this line from the aux to the main fuel tank. And then also the main fuel tank is, let's say, separated. And now you want to install it back, but now you need to connect and close the valve. If the valve is not closed, the lever will stick out and there will be a clash with the outer wing. So you basically cannot mount it. And so that is a visual inspection that you don't forget to close this valve. Otherwise, if it's not connected and you will not get any auxiliary fuel also. So that is the reason. All right, now how the installation look like for you. This is the center panel, which is beside your legs. And here's the mechanical fuel selector valve, but there are also two electrical switches. And you get one switch for each side of the fuel tank. And as said, the fuel tanks have three modes: automatic, auto, off, on. You can also see two LED lights, and there will be also two fuel gauges, which will indicate the amount of fuel in the auxiliaries. Now, to the first auto mode. The auto mode, as described, is connected to the fuel sensor in the main fuel tank. And once it is floating down, it will pass the electricity to the valve. The valve will open and it will fill up and switch off the fuel valve again. You can also, and at that time, you will get a green indication, a green light indication, because then you know, now the feeding process of the main fuel tanks is going to happen. So then you get this indication. If you switch them manually off, they are just switched off, so you can't use the fuel. And if you switch them on, it's an electrical override of the auto mode. So then you also pass electricity towards this electrical valve, and then you open it. We do not recommend that because then you have to monitor the level of your fuel tank, as we keep both fuel tanks totally independent from each other, meaning both have their own fuel filler cap and both have their own ventilation line. Because they have their own ventilation line and not a combined ventilation, if the main fuel tank is completely full, but you open the valve from the auxiliary, you would just spill out the fuel from the ventilation line in the main fuel tank. And to avoid that, we have the auto mode with the connected sensor, or you keep it off, or you keep it in the auto mode. But if you have reached a certain level, let's say maybe 30% of fuel in the mains, you can also just switch it on without any issue. Okay, that was the auxiliary fuel tank. I hope you like what you see. And if you have any further question, let us know and see you next time. Goodbye. Thank you.